On to question 6.4. For which values of x will g, and then open close brackets, x plus 5 degrees minus f, open close brackets, x plus 5 degrees be less than equal to 0 in the interval where x is an element of square bracket, open and closed, minus 90 degrees and 0 degrees. So let's start with the x is an element of square bracket, minus 90 degrees and 0 degrees, close square bracket. The first thing I want to say is we are dealing with the x-axis. So what we can do is we can write it down there. On the one hand, we have minus 90 degrees. And on the other hand, we've got 0 degrees, but we're working with square brackets, which means it's equal to, and it'll be, x will be greater than or less than 0. That tells us the area that we are working with. The next thing is, I'm going to simplify the method. I'm simply going to say gx minus fx is less than equal to 0. So let's just forget about the x plus 5 part, and this can then be stated as gx minus fx is equal to 0, and gx minus fx is less than 0. Let's start with the first equation. Where on the graph is gx minus fx equal to 0? And that'll be the place where they intersect. And it happens in two areas, over here and over here. So the next part is we want to know where gx is less than 0. So in other words, gx must be a negative value. We want to know where gx is a smaller value than f. And you'll see it's exactly where it crosses to where it crosses again. We're looking at the place where gx is less than, and this is the area we're looking at. So basically, we've covered this over here. So what we've done is we've determined the sector we're working with. And more than that, in the sector, we're working specifically with this area where x minus fx is less than equal to 0. The next step is we have to figure out this value here. But remember, the graph repeats itself, and we're talking about both graphs repeat itself. Nothing changes. Therefore, this over here will be exactly the same over here. So the distance between A and 90 will be the same as the distance between minus 90 and where we want to be. And how do we determine that? Well, you simply just say 90 minus 60, and that'll be 30. And therefore, the distance over here will be 30. Therefore, this will be minus 60 degrees. So originally, when I tackled the problem, I went gx minus fx is less than equal to 0. What they've now gone and done is they've made it a little bit more complicated by adding plus 5 degrees. Minus fx plus 5 degrees is less than equal to 0. What's happening in the gx graph is happening in the fx graph. Well, now we're adding 5 degrees to it, but at the same time, we're adding 5 degrees to fx. And when we add, we move to the left, and when we subtract, we move the graph to the right. So both graphs are moving to the left. Therefore, what we're saying is we're adding 5 degrees to both graphs. So let's just call this point T, that point S. Therefore, all we're doing is we're taking T and we are subtracting a further 5 degrees. Therefore, T now becomes 65 degrees, and S, we're doing exactly the same, now becomes, minus 65 degrees, and now becomes minus 5 degrees. If we got that, then we know X is in the middle. On the one hand, we have minus 65 degrees. On the other hand, we have minus 5 degrees. Greater than equal to or less than equal to. Or we're working with the x. We're working with the x-axis, and it'll be a square bracket because it is including minus 65 degrees and minus 5 degrees. Thank you for watching the video. If you have any questions, please drop your question in the questions below. We'll read and respond as soon as possible. If you need more help with math, please click the link below that goes to my channel and go view what we have available there.